All right, this is the Focus 2 lesson of rational expressions when you have non-common denominators. So it's going to be a little rough, but first we have to go over just some skills that we need that we've learned before, but they're going to come up. That's just kind of not part of the main lesson, but we need to be able to do them. So first, like just basic distribution, you have some term outside in front of parentheses, and the parentheses have stuff inside. There's a multiplication there, and you need to multiply through the parentheses. Basically, you're giving it the front term to both terms through multiplication. So 2x times x is 2x squared, and then 2x times 5, but it's minus, so 2x times 5 is 10x. So the numbers get multiplied, and the x just comes with it. Next, this is what we call FOIL before, but it's really just the same distribution. It's just that each term in the front needs to get multiplied to each term in the back one time. So the x times the x is x squared. If you did the FOIL acronym, the outside terms would be next. It doesn't matter. Just make sure each of these first two terms get to each of the next two terms one time each. So this is plus 7x. Inside terms, notice both the x went to both of the terms already now. So then we have negative 4x was next. So it's because it's a negative 4 times x. And then we have a negative 4 times the 7 as the last term, which is a negative 28. And then the only other thing is that these two terms, which is what we're about to get to in the next spot here, are like terms. So they are like each other. They both have an x. The x squared is not like any of the other ones. The 28 is not like any of the other ones because the 28 doesn't have any x's. The x squared has two x's. It's x squared. And then these two just have one x. So we got to be able to add those together. They're like terms. So this turns into x squared is the same. We combine the 7x and the negative 4x. So that's plus 3x. And then minus 28. So that's what we call foiling, but it's just distribution. And then combining like terms, this should be a little familiar. Just kind of go by, and I'm going to start with the term with the most amount of x's. I see that one. There are no others like it. So I'm writing it in standard form, meaning that the term that has the most amount of x's should be written first. Negative 2x squared. Okay, I did that one. It's gone. Next, I'll look for any terms that have just an x. So that would be like this one, this one, this one, and that's all of them. All of those can be added together. So there's a 1 in front of this one. Doesn't show it, but if it doesn't show a number in front of a variable, it's always a 1. So we'd have a negative 4, and then a 1 makes negative 3, and then plus 3x. That would be like negative 3x plus 3x. So there's no x's. That term just completely disappears. So negative 4x plus 1x plus 3x are no x's, so we don't write it. They're all gone. They eliminate each other. And then the last would be just the numbers that don't have they don't have an x, so we can add those together, and you just get plus 3. So adding like terms from all of this right here gives you this. All right, that's just some preliminary things we need to be able to do. Next, we need to be able to see, just kind of recall what it means to make a common denominator. So right now, we should know that we can't add these two fractions. They don't have the same denominators. But we need to start thinking about in terms of, like, what could 12 be turned into in order to make it look like the other one, just so we can see what is needed for the other one. Clearly 3 needs something with it to turn into a 12. And a lot of us remember that we could just multiply it by 4 to get to 12. And that's great. But what if this is kind of a different way of thinking about it, or just maybe the same way, but a different angle, is thinking that like 12 is really just 3 times 4, right? And it's really easy to see that, well, this denominator already has a 3. The only thing it needs then is to be multiplied by a 4. But that's changing the bottom without changing the top. So I should need to change the top too. So really I'm just multiplying both the top and bottom by a fraction 4 over 4. And recall, we're not changing this. We're not cheating. We're not changing this thing, because if we multiply it by a fraction 4 over 4, we're just multiplying it by a 1, and that doesn't change it. So what ends up happening here is you get 5 12ths, which is what we had. And then this now is changed. The bottom is 12, which is what we wanted. Now we can add the tops, but the top up here changed. It's now 8. So we would get 13 over 12. Okay, so that's what we learned, in 7th grade or whenever it was, about making a common denominator to add fractions. And it's the same thing when you have variable expressions as denominators. So that's what this is going to look like here. Here's some tips too. It's not a bad idea to change the subtraction sign to add the opposite right away. You can do that. That would look like this. Add the opposite just means you're changing this to a plus, and then anything after it changes its sign. So this 5 looked like it was a positive 5, but I changed this, so the next sign over gets changed. Now it's a negative 5. That's what this first tip means. You can do that. I made that a habit a long time ago, and I always kind of did it, and I realized that many people don't think of it the same way or care. So I'm not sure how often I've been teaching that way lately, but that is a good thing to remember you can do. It just creates less problems later. Next, think of just finding which denominator is missing something that the other one has. So notice this one on the left, you have an x minus 2 and an x plus 6. They're being multiplied together. And I could FOIL this, but I like that it's broken down right now to see its parts, because then I can compare it to the other denominator to see what this denominator is missing. So this is an x minus 2 and an x plus 6. This is an x minus 2. It needs an x plus 6. So what I would have to do then is multiply the bottom by an x plus 6. But if I do that to the bottom, I have to do that to the tops as well, because I can't just change only the bottom. And so now this fraction right here that I'm multiplying this whole fraction to is just 1, because it's the same as top and bottom. So I'm not changing it. I'm just making it look better. So now the denominators should be the same. We have the same things on the bottom. The top needs a little work, because right now we have, if I wrote this a little bit cleaner, it would look like negative 5 x plus 6. And as we showed on the first slide, that this is something we can distribute. So I just took this off to the side to distribute and see what I get. And it's going to look like this. That would be negative 5 times x is negative 5x. And then I have negative 5 times 6 would be a negative 30. So that's really what this top is here. And on the bottom, we still have x minus 2 and x plus 6. But the whole problem was that we were adding these two fractions. Finish writing this, x plus 6. We're good to go. This is the same as day 1 at this point. They have identical denominators. So I can combine these two fractions. I can combine the two fractions and just combine their tops. So it's going to look like 2x plus negative 5x minus 30 over x minus 2, x plus 6. And then there's two things that we can do here. One, the bottom is, we could simplify that. That's something that we can FOIL. So in the key, you're going to see that as something that gets FOILed. So I'll take this over here, just see what it's supposed to look like. The first terms is x times x is x squared. Outside terms would be x times 6, positives, 6x. The inside terms would be negative 2 and x, multiplied is negative 2x. And the last terms, negative 2 and 6, is a negative 12. And we can combine the like terms in the middle. Those are going to be added up to be 4x. So really the denominator should look like this. Okay, that's just the denominator. So we have that good to go. X squared plus 4x minus 12. On the top, we have a couple like terms. You have the x's here, and then 30 is the odd man left out. It's nothing like it. So we're just going to combine those two. That's a negative 3x when you combine them, minus 30. This is your final answer. So it tends up being a lot of step-by-step work, and I would keep on referring to this page, this slide right here, or this last segment of this segment of the video, because it describes every single piece of everything that you would need to do. So we'll try another one. Here's a different problem. Okay, so we'll see that like we have the denominators. You see them, x plus 4 and x minus 1. This one has x minus 1. It's not the same. It's going to need something else. So, like I said in the first step, the first tip before, you could change this thing to adding the opposite. I'll show what that looks like right now, but I'm going to save it till later to show that you can do it both ways. If I change this to adding the opposite, I now have to change. I have to put the opposite of everything following it on the top. So now this would be a negative 3x and a positive 5. And as long as this is now a plus sign, it will be the rest of the way in this problem. And these will be, you know, what they are right now until we do something with it in a minute. I'm not going to do it that way. So you'll see what happens here without it. And it's not a big deal. So I need to multiply this fraction to get the denominators to look the same. So this is going to need a x plus 4 on the bottom and an x plus 4 on the top. Now the denominators would be the same. I'll just put this over here. We would have on the bottom, you're going to have x plus 4 and x minus 1. On the tops, I'll put the 5x right now, but I'm going to have to do something with this rest of this stuff. So this right here is going to need to be fixed before I start throwing it in there. I'll take this off to the side and mess with it here. This is 3x minus 5 times x plus 4. This is something we have to FOIL, and if you did, you'd end up going like this. Again, first terms are 3x squared. That's 3x times x. Your outside terms, 3x and 4, multiplied together are 12x. Your inside terms, negative 5 and x, multiplied to be negative 5x. And then your last terms, negative 5 and 4, multiplied to be negative 20. Notice you have like terms there. Those will end up turning into a 7x. So when it's all said and done, we have to remember one thing here. We have, this was a subtraction sign, and it still is, so we're subtracting off. Now, we combine those like terms, all of these three terms. So this should be in parentheses here. If you don't put in parentheses, then we have a problem because we didn't change this thing first off. If we did change this thing first off, we wouldn't need to put this in parentheses. This would be a plus sign, and that's why. But just to show what would happen, this is 3x squared plus 7x minus 20. And we're near the last stages. We can FOIL the bottom, make it look better. And then we also need to just add like terms on the top. However, this is a subtraction sign, and all of these signs need to change. Kind of think of this as having like a 1 right here. And since it's a subtraction, if I showed it now, if I did add the opposite, this is a negative 1 that would need to get distributed to everything. So we want to think in terms of that. We want to fix that first. So this would look like, let's get a different color. Right. Sorry, pen stopped working. So then this is, the top is going to look like, really, this is just the top, 5x. The signs are all going to change, so it's going to be plus a negative 3x squared And then this -1 would go to the 7x and become a negative 7x. The -1 would go to the 20 and become a positive 20. Notice I wrote plus and negative here. That was just for the first one because I had a plus sign right here. And then I did the negative to the 3x. So in any event, we can add all these like terms still. I still have the same stuff on the bottom for right now. X plus 4, x minus 1. We should FOIL that when we get a second. The top will look like this. Like terms, we see that negative 3x squared, there are no other x squareds. So we're just going to have negative 3x squared on top. We used it, we're done with it. Next, 5x and negative 7x, they both have x's. Add them up, negative 2x. And then 20, just 20. There's nothing else like it. The bottom, I can write this there, but it's not as simplified as it could be. We should FOIL this. So if I take this off to the side and FOIL it, I would end up getting, I'll write this out just for more practice, but we should be good at this. We've done this numerous times at this point. First terms should give you x squared. Last terms, or outside terms rather, should give you negative 1x. Inside terms give you 4x. And your last terms should give you a negative 4. And then you're adding your like terms in the middle, which is a 3x. So we have the denominator now FOILed out. It's x squared plus 3x minus 4. And then this is the final answer. It took a lot longer to do because I'm explaining every single step. Once you get the hang of it, it's just the same routine over and over again. We can try, I would say, yeah, things to keep in mind, remember, really the main thing that we're going to have problems with are forgetting to, maybe missing a step in FOILing or adding up like terms incorrectly, like adding up an x squared and a 7. That's going to happen to people. That's your like terms got to be only ones that are like. I'd say the most common mistake is going to probably be when you have the minus sign here, just to know what to do with that. Again, you could have changed it right away. Then it would have been a plus sign the rest of the problem. And it would have really, what would have happened is this would have looked like this was a plus, this was a negative, and this was a plus. And when we FOILed these two things, you're going to get, all these signs are going to change and are basically going to look like this. We could try one more. That really doesn't. This is like number 2 from the actual homework. So I'm going to go ahead and do it this time. I'll change these signs right away. This is going to be negative x, and now it was a plus 2, so I'll say it's a negative 2 now. I'm doing that just to kind of show what would happen. Notice the denominators. This one has an x plus 3, x minus 6. This one has an x minus 6. It needs an x plus 3. Order doesn't matter. So this is x plus 3 now. And we're going to need to FOIL these two things to see what we got. So you can take that off to the side if you want. I'll take it over here since I have a lot of room and I'm just editing this. It looks like a negative x minus 2 times x plus 3. When you FOIL, you get a negative x squared, a negative 3x, a negative 2x, and a negative 6. Then when you add like terms in the middle, negative x squared minus 5x minus 6. That whole top now, right up here, turned into this. So really what we have left over is 3x minus 1. And I can combine these two fractions now because I have a common denominator. So I can just put the denominator on the bottom. It looks like x plus 3, x minus 6. Okay, then this plus sign is good. I already changed it, so it's plus. And then whatever else I got to write now, I don't need parentheses for. I already changed that sign. So this would be a negative x squared minus 5x minus 6. At this point, it's just adding like terms. So then you would have negative x squared. It was the first term. There's none like it. I have a couple x terms, 3x, negative 5x. Gives you a negative 2x when you add them. and then you have a -1 and -6 is a -7. And the bottom, we can FOIL that. We should get good at that soon. We've had to do it numerous times. So then you'd have x plus 3 and x minus 6 that you're FOILing. You're going to get x squared minus 6x plus 3x minus 18, and then combine like terms. That turns into a -3x. So finally, this is x squared on the bottom minus 3x minus 18. And then this is your final answer. All right, give yourself a high five because that's a lot of work. All right, good luck. Please ask questions as they arise because this is kind of heavy because there's a lot of steps to these processes, but like it's all stuff we've done before, and just keep going back in the video when you forget about like